Hi class, this is section 3.5, Proving Lines Are Parallel. Our learning target for today will be that we will be able to prove that lines are parallel using properties of special angle pairs. So up to this point, we've been given that lines are parallel, and then I asked you to find missing angles or special angle pairs or the relationship between angles. Well, now we're going to go in the reverse order. I'm going to give you angles, and you are going to have to say whether or not the lines are parallel based off of those angles. Before we start with that, we're going to do a quick warm-up. This asks us to find the value of x and to justify each step. Then finally, we'll find each angle measure. So first, looking over at my picture, I have two parallel lines, and I have two angles. The special angle pair going on between these two angles is that they are consecutive interior angles, which means that they are supplementary. So my first step that I'm going to do is I'm going to set those two angles equal to 180. The reason that I can do that is because consecutive interior angles are supplementary, which is using the consecutive interior angle theorem that we learned about last lesson. Now I'm going to simplify by combining like terms on both sides, on the left-hand side. I'm then going to subtract 20 from both sides, and finally divide by 8 on both sides to get that x is equal to 20. Now I need to go back and find each angle measure. So I plug in 20 to here, which would be 100 minus 25, gives me 75. Then down here, I will have 60 plus 45, which gives me 105. So 75 and 105. So all of the theorems and postulates that I'm going to give you today will be converse. So if you look back to last chapter and what a converse was, it's where you switch the hypothesis and the conclusion. So all of these theorems will just be flipping what you've already learned. The converse of the corresponding angle postulate says if two lines in a transversal form corresponding angles that are congruent, then we can say the two lines are parallel. So below we're going to look at a couple of pictures and we're going to find the parallel lines in the pictures. So if I can find two corresponding angles that are congruent, then I can say that the lines are parallel. In the first picture, we have these two angles of 45. I can see that they are congruent, and I can also see that they are corresponding angles because they're both on the bottoms of these two lines, and here's my transversal that they're on the same side of. So my two parallel lines are right here. Next one. I'm looking for congruent angles, so immediately I see this 90 and this 90. Now I need to decide, are these corresponding angles? Well, they're both on the right-hand side of these two lines, and they're on the same side of the transversal. So yes, they are corresponding angles, and yes, they are congruent. So I can say that these lines are parallel. I cannot say that the top and bottom are parallel. Even though these are corresponding angles, they are not congruent, which means that these two lines right here are not parallel. And then the final picture. I look at my two 37-degree angles. I see that they are congruent. This one's on the top of this line, this one's on the top of this line, and they both are on the same side of the transversal. So my parallel lines are going to be here. Now we have the converse of the alternate interior angle theorem. If two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. We're going to do the same thing that we did before, and we're going to find the parallel lines in each picture. So here I do have two alternate interior angles, but they are not congruent. They're supplementary. So in this picture, I cannot mark any parallel lines. The next one, I see two alternate interior angles. Here's my transversal, and here are my two potential parallel lines. Since my alternate interior angles are congruent, I can say that these two lines are parallel. Now we have the converse of consecutive interior angle theorem. This states that if two lines in a transversal form consecutive interior angles that are supplementary, then I can say the two lines are parallel. So remember, we're looking for supplementary this time. So looking at our picture, I see that 70 and 110 are supplementary, and I see 180 are supplementary. So these two are the consecutive interior angles for this side. These two are the consecutive interior angles for this side. Since both pairs are supplementary to each other, I can say that the top and the bottom are parallel. Next picture, I have 75 and 115. Now at first glance you may think that these are supplementary, but these two angles do not add up to 180. They add up to 190. So in this picture, I don't have any parallel lines. Now we're finding the converse of the alternate exterior angle theorem. If two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. This time I want you to solve for x so that lines M and N are parallel. Well, for M and N to be parallel, these two alternate exterior angles have to be congruent. So I need to set them equal. Then you're going to solve for x, and you will get that x is equal to 28. Given the following information, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. So if I told you that angle 2 was congruent to angle 8, could you say that lines R and S were parallel? Those are the parallel lines, and line V is the transversal between these two angle pairs. So these are alternate exterior angles, and I'm telling you that they are equal or congruent. So yes, I can say that R and S are parallel, and it's because of the alternate exterior angle converse. Now I'm looking at angles 12 and 13, and I tell you that they add up to 180. So that means they're supplementary. So they're on the same side of the transversal T, and they're between the lines R and S. Since these are consecutive interior and they are supplementary, I can say that lines R and S are parallel using the consecutive interior angle converse. I want you guys to try the next three on your own, and I will put up the answers in a second. You may want to pause the video. Alright, angles 4 and 6. These are alternate interior angles. I can see that they are congruent, so I can say that lines R and S are parallel using the alternate interior angle converse. 14 and 15 are congruent, and that is true because they're vertical angles, but we do not have a theorem saying that vertical angles make parallel lines. So this one would be no, that I can't use anything to show that any lines are parallel because I'm just given vertical angles. And then 9 and 13, these are corresponding angles. I can see that they're congruent, and that should be right. Corresponding angles are congruent, so I can say that R and S are parallel using the corresponding angles converse. Now I want you to find the value of the variable that would make the lines parallel. State what postulate or theorem justifies your answer. So looking at this picture, these two angles right now, do not have any special angle pair in common. What I can do is manipulate this picture a little bit so that I can set up a special angle pair. If this angle is 80 degrees, then I know for a fact that the vertical angle across from it is 80 degrees. I don't need to know that there's parallel lines in order to put that. Vertical angles are always congruent no matter what. So now I have a special angle pair that I can try to use to set x equal to a number so I can say that these two lines right here are parallel. So these would be consecutive interior angles, which means that they need to be supplementary. So I'm going to set up an equation setting them equal to 180. Then I'll combine like terms, subtract 50 from both sides, and get that x is equal to 65. So again, I know that the vertical angles are congruent, which gave me a special angle pair. Now I need these two to be supplementary for this line and this line to be parallel. So we added them equal to 180 and then did the math to solve for x. Alright, the next picture can be a little tricky to look at, so I'm actually going to point out where the transversal and the lines we're trying to prove parallel are. So here are the two lines that we are trying to prove parallel, and this is the transversal. Knowing that, you can see that these two angles right here are corresponding angles. In order for these two lines to be parallel, these corresponding angles need to be congruent. So we're going to use the corresponding angles converse. Since they're congruent, I'm setting them equal, subtracting 2x from both sides, adding 40, and finally dividing by 2 to get that x is equal to 40. We have two final theorems to go over. The first one says if two lines are parallel to the same line, then they are parallel to each other. So here I have two parallel lines. Then below I have that the two green lines are parallel. Since the red and green are both parallel to the same line, I can say that those top and bottom lines are parallel to each other. And then our second theorem. If two lines are perpendicular to the same line, then they are parallel to each other. So remember, perpendicular means that they form a 90-degree angle with each other. If I have two lines perpendicular to the same bottom line, I can now say that those two lines are parallel. Now let's try a proof to put this all together. I promise I'm going to go step by step with you, and we're going to keep practicing proofs, so don't be scared. Alright, so in my proof I give you that angle 1 and angle 3 are congruent, so I'm going to mark that in my picture. And I also tell you that AC and BD are parallel. So those are my parallel lines in the picture. I need to prove that AB is parallel to CD. We're going to have to use a converse theorem because that's the only way you can show that lines are parallel. So first step we always know is the given. Now let's look at this. If AC and BD are parallel, can I say that any other angles in this picture are congruent? Well, angle 2 and 3 are going to be corresponding angles, so I can say that they are congruent because corresponding angles are congruent. Now that I have the angle 1 is congruent to angle 3 and angle 2 is congruent to angle 3, I can say that angle 2 is congruent to angle 1 by using substitution, just plugging in this angle 1 for angle 3. So now I'm saying that angle 1 and angle 2 are congruent. Well, do angle 1 and angle 2 have any special angle pair in common? Yes, they do. Those two angles are going to be alternate interior angles. Since I just told you that those two alternate interior angles were congruent, we can then say that AB is parallel to CD. So